we have concluded the Python course. I mean the quick, not complete Python course. It's a quick startup Python guide to start our cloud journey. And I'll request you guys, please go ahead and try it out from your end. Please do hands-ons. Please try out few things from your end. And if you face any issues, please do let me know, and we will sort it out. And just for your practice purpose, let me just share the notes here. So you will need this is the one string manipulation and class. So here I have uploaded all the notes for the Python. You can download this from here and start doing practice. And today we are going to start our cloud journey, and I'm going to start from very basic of the cloud. So first of all, today I'm just going to introduce you what is cloud engineering and what are the benefits and features of the cloud engineering. So as per the definition of cloud computing, or you call it cloud engineering, if I say in easy language, there's no new concepts, okay? There's no, I mean, hardware, resources, your memory, your logics, your programming languages are not new. Just the way you access those things are completely new. They have more features. They have they are more easy to access. They are more cheaper, and they are very readily, very quickly available as on-demand basis. So as per the definition, cloud computing is a on-demand delivery of IT resources over the internet based on pay-as-you-go pricing. That means if you use those services for 1 hour, you are going to pay for 1 hour. So it's the kind of rental services that we are using. So instead of buying, owning, and maintaining actual physical data centers and servers and tools, we can simply go ahead, open the internet, open any cloud, be it Azure, AWS, or GCP. Okay, go on the console, request for the service that you would like to access, and just use that. And the amount of time or amount of resources that you use, you are going to pay for that. Okay, so that is what a simplest definition of cloud engineering can be. Then what are the benefits of cloud engineering? It is agile, first of all, as I mentioned, as and when you need it. So if you need it now, you can just go ahead on AWS, create your account, and start using those services. Right now, obviously, you guys do not know those services, but we will see those things. Okay, but agility here refers that we are flexible to use them as and when we need it. Those services will be available for us. Elasticity refers to the amount of service we need. Okay, so let's say today we need 10 GB of storage. Okay, and we can get 10 GB of storage. We can upload our data and we can just pay for 10 GB of the storage. But let's say in future we need 100 GB of storage, then we can go ahead and store 100 GB of data, and we are going to pay for 100 GB of storage. But let's say on the same service, you don't need 100 GB, you only need 5 GB. So you can just remove your data, keep using 5 GB. So it is like, it's very elastic. That means if you need more resources, more availability will be there. Just you have to pay more. If you are not needing more resources at any particular moment, you can just remove or terminate those resources, and your charges will be reduced down. Third benefit could be your cost savings. So let's say if you guys have ever heard about this Hadoop. Okay, so it is not easy to install a Hadoop cluster, manage a Hadoop cluster, configure that, and connect that and secure that, and all those things are not so easy. And a lot of brainstorming is actually needed for that. So if I give you an example, let's say there is a project, okay? They want to do a POC. Let's say they want to move from mainframes to Hadoop, and they want to do a POC, okay? Now, first of all, they'll have the leadership will have to decide how many nodes we need, how much data we have, who will be responsible for managing those servers, who from where we will be purchasing those servers, okay? So those kind of decisions you have to make. And let's say you have purchased a 6-node cluster, and your actual requirement was of like the data you have is around which is needing at least 15 GB of node cluster. So it is like you have under provisioned the cluster, and now to upgrade that you again have to do meetings, a lot of brainstorming, a budget has to be finalized, and these things actually take time. So by time I mean they can take months, and these months, let's say if I say least, at least 3 months of time has gone in setting up the cluster. You have not done a single thing on logic side, or you haven't got any output from your investment, at least for starting initial 3 months, okay? And other problem, it could be like you have purchased a 15 nodes cluster, but your only requirement was 2-node cluster only. In that case, you are over provisioned and you are wasting your resources. Like you have paid too much money to buy those resources, and now you have to bear those resources, and they are not even utilized. So those kind of costs are not uh, those kind of cost is not charged on the cloud. So you can say there is no capital investment to start any POC or start a project, or even running a project in a production environment. There's no capital investment is required. You can start from 0 rupees within a minute or within hours. You can start, okay, and we just have to pay for operational expenses. That means the amount of time, the resources we are using, we just have to pay for that much time, and only the operational expenses we have to pay. And obviously the final benefit which I have listed here, that is deploy in minutes. So let's say if I want to right now also, if I think and plan that I need a 5-node Hadoop cluster, I can go on AWS and launch that, and it will be available to me in 15 to 20 minutes. So just compare this thing, okay? If you want to launch a 5-node cluster in on-premise basis, if I talk about 5 to 10 years back, we had to do a lot of brainstorming, and then we have to purchase those things, do some agreements, and then the server would have been made available to us. And we have to manage with a 5-node server only. But with the cloud, we can say right now I need a 5-node cluster, but in future, if I see more requirement, I can just increase within a few minutes from 5 to 6, 6 to 7, like that. I can increase my nodes. Or if I do not see any requirement, if I see my cluster is idle, I can reduce down my number of nodes to 2 nodes also. So on cloud, there's a flexibility, there's a elasticity, like there's a cost saving. You can start early, and most practical thing I'll say, you can start on the product development instead of doing brainstorming, instead of wasting time in purchasing resources or managing resources. You can directly start from writing the code and getting the output from your code, and you can show your business, okay, this is the POC I'm doing. I had this idea, and this is the POC I'm doing, and this is the final product that we have, and it is going to benefit you in this use cases. And it can maybe automate some things for you. It can save some time for you, or it can save some cost for you, or it can increase the visibility of your product. So actual results we can start getting within a very quickly. We can start getting those actual results instead of just thinking about that we will do POC. And what used to happen, a lot of POCs were cancelled due to this, okay? Let's say if I have an idea, okay, I'm working in some project and I have an idea, and for that I need let's say I need a Spark cluster for that, okay? Now if I go to my manager and if I say I need a Spark cluster of 4 nodes, then it will be around, if I just giving completely assumed requirement. Okay, so let's say I need $1,000 of investment from this project, and then I will do a POC for you, and I'll show you some automation that can enhance the productivity of our team or of our company. But obviously that particular manager cannot give you the $1,000 from his pocket. Okay, he has to go to his leadership, his managers, senior managers. They have to decide. And obviously if a junior developer comes to you like this, uh, chances are that project is not going to approve. And $1,000, I'm saying very least amount. Okay, that amount could go to $5,000, $10,000 also. So in such scenarios, a lot of POCs could not happen. And that is also the reason I think personally that nowadays demand for data engineering is very much increased, because right now also in my project, whenever we think about some POC or some automation we think about, we can simply just go on cloud and run those resources in 5-7 days. Because from day one I can start writing my code due to this cloud flexibility. I start writing my code in 2 or 3 weeks after spending $50 to $100. I have that final output with me. I can present that to you, that final output to my leadership, and if they approve, that will go in production. If they don't, and then some amount is just wasted, but not huge amount is wasted, not huge efforts are wasted. So it's saving cost, resource, time, efforts, everything is is beneficial on the cloud. That is why you see a lot of demand in cloud engineering, or specifically in the cloud data engineering segment. So this is all for the cloud introduction part. If you have any questions, you can let me know. And just a second, now I'll be muting.
Yeah, I have one question. Just now you mentioned you'll be creating some kind of prototype and
Sorry, Vasa, I was not there for 30 seconds. Can you please repeat?
sorry. Yeah, you were saying that you will be creating a prototype.
I'm actually having difficulty in hearing you. Is it just everyone?
And now it's fine.
Yeah, I mean when you speak louder, it's
I
fine.
can't hear what she's saying, Varsha.
Oh, I see. It seems to be Varsha voice is very low or something network issue from our side, I think.
Okay, and now it's fine. Now,
Yeah,
Yeah,
it's
yeah,
fine
fine.
now.
okay. So when you were saying like you will be preparing a prototype and presenting to the leadership, so
Mm-hmm.
uh, uh, it's a kind of development you are doing, development work with a smaller data set, or developing something new as a part of POC.
So, see, in my project specifically, I am doing a development with some smaller data set or maybe full data set. But for that, the resources I need, let's say I need some resources. Those resources are available to me with very cheap cost. Okay. And obviously for POCs, I will also recommend you to you guys also when you're learning these things, start with smaller data set, because these things are rental basis. So if you see, your logics and your concepts can be proved with a 100 MB of data set also. And if you go with a 1 TB of data set, then it's the same thing. Your logic, your approach, your final output is same. It's just that if you work with 1 TB of data, you are going to pay more charges. So for POC, I will say POCs, practices, I will say work with smaller data as possible. Even 100 MB, I'm saying it's too much. Work with like KBs of data, like 100 or KB, 500 KB data is sufficient.
So right now like in we will be having development environment, and then UAT, SIT, and then we will be having prod environment. So in case of this AWS, how does it work? I mean, they will be having set how, because AWS works on account basis, that I'm sure. So how this development and pre-prod everything works?
So it is actually based on AWS organization. So within a AWS account, you can actually have multiple sub accounts. Okay, so and it also depends. See, there are two ways. Okay, first of all, you can use AWS organizations to separate your development account, to separate your UAT or SIT whatever account, or and the production account. Okay. And you can also use IAM roles. So based on IAM roles, you can give accesses. Okay. So there are two approaches, and the better one is obviously the AWS organization. So it's like if you learn about the AWS organization, there's a main root account on top, and inside the root account you have 3-4 accounts, maybe for different regions, or it could be one root account then has more accounts. So it's like if I just open an Excel sheet. Mhm. Just learn about this AWS organization, and it's not our responsibility, the data engineer, to create a AWS organization, but just learn about this if you're interested. So it's like you will have a root account here. Okay. Inside this, or you can say under this, you can have a finance, and you can have marketing, and what is happening now? Marketing, and you can have HR. So it's like these three accounts you can create under one root account, okay? And then if finance can have QOT and prod. So like this, you can have this organization account, and your bills will be generated for this root account. Your IAM policies will be managed by these accounts, and every account can have their own IAM policies and like that. So it's like a combination of accounts you can create.
Okay. My second question is, suppose you in your company new team has come and four people has joined newly. So for all these four people, different user ID password, as in just like we log in into AWS console, the same way we will be getting separate four different user ID and password.
Mm-hmm.
So this is how we log into real-time AWS as in project wise, right?
Yes.
Okay.
So I think I didn't get your question clearly, but you said, let's say there could be many users and they log in into AWS account from their own ID passwords. Yes, it is correct. And those ID passwords are actually generated by a service called IAM, that is Identity and Access Management. So that actually we are going to see in this course, maybe today, maybe Tuesday next week.
Oh, got
Okay. So see, one thing let me make very clear to you guys. Okay, so as you guys are moving new to cloud, one thing you have to very be specific, and we have to be very clear that nobody can learn each and everything of any cloud. Forget about AWS or Azure. It, on any cloud, you cannot learn anything. Okay, because on cloud you have networking roles, you have security roles, you have machine learning roles, you have BI roles, you have data analysis roles, you have data engineer roles, you have application development role, you have web engineer roles, you have IoT roles. So you have to be very specific towards what you are looking to do. So right now in this course, we guys are looking to become a data engineer. So technologies and tools required for data engineers, or which are mostly used, we are going to cover. But I'll request you guys, do not get diverted into learning all the cloud, because going for all, it's I'll say in such an initial stage is can be a disaster. Okay, nobody can learn each and everything of cloud. So if I open the cloud console, I will open that in a few minutes, and I show it to you. There are a lot of services. Okay, we have to be very careful with our approach. So it is like in generic terms we say now, we should focus on our goals. We should not see what others are doing or what is my neighbor is doing, what he is trying to become. We should focus on our goals. Okay. So right now I just gave you an example of AWS organization. So I'll say you can just go and learn about this. Okay, learn some blog, what it is, and what features it is providing. That's all. Do not try to go and master this, because this is a tool utilized by security or admin engineers. It is not a data engineer's duty to create these separate accounts. Okay, so just focus on your goals and continue on those. Okay, so moving ahead, there are types of services that we have in a cloud. Okay, majorly those are called as infrastructure as a service, platform as a service, and a software as a service. So infrastructure as a service means you are renting a resource from a cloud, okay, where you have to maintain its state. That means there's a there's a tool or there's a service called in AWS, that is EC2. EC2 stands for Elastic Compute Cloud, and with help of EC2 you can actually go ahead and launch virtual machines. So if you understand this thing, like in our project, sometimes when we work for consultancies specifically, so we log on into our laptop or desktop, then we used to go and do RDP on some virtual machine, and that is the client's virtual machine, and that is where actually we work. Okay, if you have ever seen that thing, so those are virtual machines can be launched from AWS also. Okay, and that service is called EC2, Elastic Compute Cloud. That means compute services we can launch from the cloud. But those EC2 is an example of infrastructure as a service. And how I'm saying that? Because for EC2, you have to maintain the OS upgrade. Okay, there's no automatic OS upgrade is going to happen. You have to maintain all the security patches, who can access those virtual machines, where they will be launched, how much memory they're scaling, if there is enough capacity of compute or not. If I say easy and one liner, each and everything will have to manage from our end. It's the responsibility of the user of the cloud that they have to maintain OS, upgrade, patches, security, and softwares. Okay, you on those services where we have infrastructure service, we have complete control, but we also have some responsibilities. Okay. On the other hand, we have a second class, that is platform as a service. So example for this is will be AWS Lambda, AWS Glue, Athena. Okay, in these services, what happened? We just go and we just select these services. Okay, we just select services and we start writing our development code or our development activities. We can start doing that, but we cannot maintain which version of Python we want to use, okay, which version of OS we want to use, security, what security patches they have installed. It is the responsibility of the cloud vendor. For our case, it's AWS. So AWS, Amazon Web Services, their team is going to take care of these maintenance activities on the resources which are actually used behind the scenes. Okay, then third one is software as a service. That is very simplest one. Like you have a software, no need to code, no need to develop anything, or no need to do any activity. You just go and start using that. So example, I'll say one of the example of software service is AWS Chime. Chime is nothing but a Skype or Zoom or Teams, you can say, where you can just go and connect with your team and just you can start calling, messaging, pinging, and check who is online or who is offline. Those kind of activities you can do, and that is a software you have. You don't have to code inside that to use that. Okay, so these are the three types of services that we have. So I'll just take a pause here because it's necessary to understand the differences. So if you have any questions in this.
So this Gmail fits into software as a service, huh?
Exactly.
Okay.
And don't worry, when we are going to launch these services, now I'm going to tell you what is where in which category it falls. And then we have a very high level architecture of cloud. Okay, this kind of architecture is actually followed by Azure also, and AWS also, and GCP also. So basically, whatever I'm teaching you right now, this complete PPT, all this theory, is actually same for all the three clouds. Okay, no concepts are changed there. Okay, like they also have the same benefits, they also have the same definition of cloud computing, and they also have the resource types like these things only, and then we have this architecture. So this architecture is the actually simple one, but we have to understand this. So this kind of architecture helps you giving three major benefits in the cloud. Okay, that is high availability, fault tolerance, and low latency. Okay, how it does, now let's understand that part. So first of all, a cloud is actually divided into regions. Okay, every cloud is divided into regions. What is the region? Region is a physical location. Physical location means not on a computer or memory, it's a physical location on the map of this world. So if I give you an example of region, Mumbai is a region provided by AWS. Hyderabad is one of the region they have just recently launched. US East one, Oklahoma is a region. Ohio in the US is one of the region. Frankfurt in Germany is one of the region, and like that we have multiple regions around this world. Singapore is one of them. Ireland is one of them, and like that we have around 18 to 20, or maybe I think they have now around 30 regions in this world. Okay, so what this region is doing, this complete region has at least two. Okay, understand this thing clearly. They have at least two or more than two availability zones inside every regions. Okay, inside every availability zone they have at least two or more than two data centers. Okay, so data center is the uh, smallest unit in this diagram. So now what is data center? Data center is the actual place where all these resources, all this hardware and storage capacities and these compute capacities are actually stored. So when we go on cloud and when we try to as some of you have actually worked with AWS Glue. So when we go ahead on Glue console and when we try to execute a Glue program, when it is executing now, it is actually running on some hardware. So for I mean this very basic thing, for any software to be run, for any software to be performed, they need a hardware. That hardware is actually stored in these data centers. Okay, now why two data centers? So if one data center is failed due to electricity, due to some natural disaster, flood, or any reason, it could be, okay, it could be hardware failure, it could be software failure. In that case, your data, your softwares, your programs will be available from its brother, or you can say it's a co-region. Okay, from the nearest region, it will the nearest data center, they will be available. Okay, same way, if a complete availability zone is gone for a toss, then if your then you can say then your data, your code, your program, your file will be available from a different availability zones. In case if complete region is gone, then it will be available for it, the services will be served from another region. That is one thing. Now this thing, when a data center is failed and another data center is actually serving you, is called high availability. That means your services are highly available. That means out of 24 hours, they are available for 24 hours. So this high availability is actually measured in percent number of nines. Okay, so if I'm not wrong, S3 is one of the service that provides 11 nines of high availability. That means if I just open my notepad, means 99 point this is the percentage of time they are claiming that your S3 will be available to you. Like around it's if I'm not wrong, it's around 10 to 15 minutes of complete year. We are saying like for 15-20 minutes in complete year it might not be available. Then in the other time it will be available. Okay. So some services has like 11 nines of, like, if I just count them, 1, 2, 3, 4, 5, 6, 7, 8, 10. I think I need to add one more 9. This is what S3 provides to you. Then some other services are like 99.9% of time. Then there are some 99.999, and like this is the way to measure high availability of any service, and it could be on any cloud. Okay. So this means for how much time in complete year a service is expected to be available to its consumers. Consumers means me and you. This is high availability, that your services are available. One thing, fault tolerance is your fault tolerance means that we are not saying that my data center will never fail. Okay. Or I am not saying that my availability zone will never fail. I am just saying they might fail, but it will not affect you. Okay. There will be a backup in other availability zone and it will be serving you. This is called fault tolerance. Okay. So understand the difference. If your service is available, that is like how much time your service is available is measured by high availability. If your service is ready to accept the faults and still serving the users, that particular thing is called fault tolerance. Okay. Just understand these keywords. It's important, and it could be asked in interviews also. This concept of high availability and fault tolerance, this concept can be asked in the interviews. So now how it is achieved in the cloud. So if I take an example of S3 again, by default, a S3 file, let's say I want to upload this PPT on S3. Okay. So right now, actually, you don't know S3. If you know that, it's good, but it's a storage service. Okay. Just for now, understand it's a storage service. So if I go ahead and store this PPT on S3, by default, S3 is going to, what it's going to do, in one availability zone, it's going to place 2 copies. Okay. So one copy will be on this data center, another copy of that same file will be on this data center, and one more copy of that same file will be on some another data center of same region. So that is, you can say, availability zone level, or you can say region level duplicacy is there, region level fault tolerance and high availability is there. If your complete region is down, then you won't be able to retrieve or get access to this particular PPT. Now, if your program or if your project has that much criticality that even if complete region is down and you want to have the access, in that case you can go ahead and replicate your files in another region. So you can also have your files in Mumbai region, and you can also have your files in Singapore region for backup purpose. And if by any chance if complete region is down, then you can access those files from Singapore region. So financial projects like banking, credit cards, insurance, where money is related, obviously they will look to have multi-region fault tolerance available. But yes, for multi-region fault tolerance available, if you're making multiple copies of your data, obviously you have to pay a bit more. So if you want to increase the fault tolerance or increase the availability of your services, you will have to pay for that. So depending on your requirement, you can choose the type of fault tolerance level you want. You can also restrict your fault tolerance on availability zone level. Okay. You can say I'm just trusting one availability zone and I just want to place my files or data on this particular availability zone, and I don't want to copy them on this particular these 2 other zones. Then obviously you're going to pay less. You can go ahead and make it a zone level copies. You can have your data here also and here also. For that you have to pay a bit extra, and you can go and completely go out of region and copy your data on a different region for a safer side. So I just take a pause now if you have any questions.
Region I'm understanding. Data center also I'm understanding. So availability zone is like a logical group of data center I can understand.
You can say it like logical group, but it's actually a physical, like physically two data centers are there, and you are actually creating a logical group. You can say like two data centers at same place. You're calling a availability zone.
And high availability means suppose one data center is lost, so has some issue, then another data center would be available. And
Yes.
it's a fault tolerance. Uh, when a file is replicated multiple times, that comes as a fault tolerance.
No. See. Concept is same. You file in the case of high availability also, in the case of fault tolerance also. The file is placed on two different things. It's just a terminology. Uh, high availability means your file is available to be accessed for users or consumers at this much percentage of time, and fault tolerance means uh, it is the same thing. Okay, if I say it like how do I create a differentiator for you? Mm. See, what level of fault tolerance you have, it's that can dictate the high availability. Okay, so if your fault tolerance is on zonal level, okay, so you are trusting one zone only. Okay, you said if one data center fails, then just give me my files from another data center. That is your fault tolerance level. But let's say your both data centers have failed in this particular availability zone, then first of all your fault tolerance has gone for toss. You don't have any backup available now, and the time it takes to recover those data centers and make them available online again is called high availability. So response on the case of failure and making the things online is the fault tolerance level. Your fault tolerance level is, you can say, is the availability zone level. Okay, it's a zonal level fault tolerance you have applied. And high availability means if you have only this much like fault tolerance on availability zone level also, in that case your high availability obviously will reduce down. That means it could be possible a complete zone is out and you might not be able to access the file for 1 hour. Obviously, in that case, some nines will be reduced from the high availability. So is it making sense to you now?
Yes.
And one more thing, just remember, it's not so important also, but yeah, it's actually important. These regions also follows government rules. Okay, so not too much, obviously not on syntax level, not on logical levels. They are there, but data compliance rules, data governance rules, some government rules are also there. And also try to choose the region which is more closer to your physical location. So if I am sitting in India, I will obviously look to choose region which are like Mumbai or Hyderabad. Maybe Hyderabad I think is still not online, but yeah, just for example I'm saying we should look for the regions which is more closer to our physical location. That is one thing. If you choose a region in the US East from the India, only thing is that you will have some latency in that. Like if you try to access something, then you might see few seconds of latency. But if those few seconds does not matter to you for your practices, I'll say go and try to launch services in US East one only, because that is the region where cost is cheapest. So depending on the region, your cost can be a different one. So you can see some cents difference, like 2 or 5% difference is there, not more than that. But if you wish, you can go ahead and choose the US East one. So depending on the region also, your price might differ slightly. Okay, so now this is all from my end, and if you have any question, you can ask. Otherwise, just let me know if you guys have cloud accounts ready with you. If not, I'll request you please go ahead and sign up yourself on AWS Web Services. It's a free process. Yet, yes, you have to provide your credit card, but it's a free process. And if you are not aware with AWS completely, please do not go ahead and try to play with it until unless I have covered those services. Okay, so just a precautionary warning I am saying: do not try to go ahead and play around. You are giving your credit card details. It is not some free tool to be utilized. Okay, in this course, if we do not make any disaster, we are not going to be charged more than 500 rupees in INR. If I say in dollars, it should be less than around $7 to $8. Okay, but just don't go ahead and play around with it. This is not a tool to play around without knowledge. Am I clear here?
Yes, Jalaj. Jalaj, I have one doubt. So for the entire course, this free account is sufficient, right? Or any charges will,
See, that is what I mentioned. So this is a free account. Some of the services are free. Some of the services are still chargeable. The course that we are covering is expect if you do a proper hands-ons, okay, you might, and if you just terminate your services after your practice is done, and if you do not create a disaster from your end, then you should not expect charges more than 500 rupees. Okay, 500 is for the complete course. It's not like a 1 day charges or a 1 week. For the complete duration of this course of 6 to 7 weeks, we should not occur more than 500 rupees charges.
okay.
So if you need my help in creating signing my account, someone from you have to share the screen and do this from your end, because I already have signed it up. I cannot show you those process, but it's actually fairly easy process. It's just like filling up a form, your name, email ID, address details, credit card numbers, doing a sample transaction of 1 or 2 rupees to just verify your credit card, and then go on console.
I have also account, so I can't help in this one.
So and let me tell you one thing also. If you have created your account, when you created your account,
2 days back.
yeah, then it's fine. See, AWS Redshift is only free for initial 2 months. Okay, so
Okay.
we have to keep in mind that.
Yes, 2 days back only I have created.
Yeah, that is fine. So just for your reference, guys, come here and check AWS free tier limits. So here you can see, if I just go on this page, and if I just remove this tick. So let's say here you can actually go ahead and see all those details, all the pricing of the services. Okay. So as you can see, Amazon S3 till 5 GB, it's free for 12 months. Okay. After that, you will be charged. So 5 GB till 5 GB, it's free for initial 12 months. Okay. EC2, you can see if you check this out here, only T2 micro and T3 micro. If I select this, only T2 micro and T3 micro are free for initial 12 months, that to 750 hours per month. If you go beyond this limit, you will be charged. If you launch a bigger instance than T2 or T3 micro, then you will be charged. Okay. Same way, if I search for Redshift here, you can say 2 month free trial is there. They do not say free, it's 2 month free trial. Okay. And same way, if I go for Glue, you can see in AWS Glue, 1 million objects stored in Glue data catalog is free, but Glue charge yourself, like when you run the Glue job, you are getting charged on the DPUs. DPUs are not free, they are charged, and we are going to occur some charges for that. So I'll tell you when we reach on the Glue how much charges you can expect. It's around, if you run your job around 10 to 50 times, or let's say 100 times if you run, you're not going to get charged more than $3 or $4. That means 200 or 300 rupees max. Okay, just check it out here, and if I just log in into console, this is how AWS Console's landing page look like. And if I just go on view all services, so you can see we have a lot of services. Okay, security, identity, management, governance services. This is what I was telling about AWS organizations. Then we have compute services, container services like Kubernetes is also there. Database services is also there, like RDS, Oracle, MySQL, Postgres. Okay, those all things are there. DynamoDB, migration and transfer services are there. Media services are there. Front-end web services are there. Cost management are there. Machine learning is there. So obviously you cannot go ahead and learn all these things, like networking is there, developer tools are there, business applications are there. So it's too much. It's way too much for somebody to go and grasp the knowledge about these things. And if I just say about this Glue, there are around 2000 pages of documentation for this Glue only. So just understand this thing, like, okay, same as this, I think, for Redshift. They have more than 2000 or 3000 pages of documentation for Redshift. So it's way beyond the capacity of any particular human to learn all this cloud. So do not expect this from anybody, and specifically from yourself. Okay, you guys are just going to start, and we are going to focus on the analytics services, and that too also not all services. Okay, Athena we are covering, Redshift we are going to cover, Kinesis we are going to cover, then Glue we are going to cover. We are going to introduce to EMR also. So these are the most famous services that are there, and these we are going to cover. Glue DW is again one of the services that you can go and explore from your end. Okay. So if you have any questions, you can ask. Otherwise, we can wrap up for the today, and we'll meet on Monday same time.
I have one question.
Yes, please.
Is it chargeable? Even development environment also is chargeable. Now, you have wrote one select query and I have written one select query. Your select query is quite optimized, but as a newcomer, I wrote a query which will take when I'm hitting, it will it is extra chargeable in terms of money. Now, is there any best practices or hard stop for this kind of activity in AWS data engineering as in production?
See, first of all, to your question, there are many, scenarios can be there. If we are running that query on Athena, then it does matter on charge side also. Okay, if your query is running for more time, then it's going to charge more. If you're running the same query on Redshift, then it actually does not matter on the charge basis. It will matter on the time basis only. Its response time will be delayed. So yes, you can optimize your query. Those query optimizations we're going to talk about in the Redshift.
So, I mean, is there mm, how we come to know the different set of queries will take how we can predict this would take some this will take extra charge or this will be uh, this is like it will happen in less amount. So how we predict this?
Okay, so for that you have to understand the charge, how this particular service is charging you. Okay, so as I mentioned, uh, you have to understand. Let's say we are running the same query on Athena and same is on Redshift. So we have to understand how Redshift charges us, okay, and how Athena charges it. So it's actually too early to answer this question without understanding the services. It's not on the query level that you're getting charged. It's the amount of data that you have scanned, amount of resources that you have used. So see, Redshift is a server based service, okay, where we have purchased something. So it is like it's like you have rented a house for 12 months or 11 months of contract you have made for a house, okay, and now if you stay in that house or if you don't stay in that house, uh, it's completely your choice, but owner is going to take rent from you. Okay, this is kind of a concept you can connect with Redshift. But on the other hand, Athena is like you're going into some city and you are going into hotels. Okay, instead of renting a house, you're just going into hotels. So it's like if you stay for 3 days, you have to pay for 3 days charges. If you stay for 1 day, you have to pay for 1 day charges. If you stay for complete month, you have to pay a lot of charges for complete months of uses. So it depends which kind of service you're using. It's not on the query level, it's a kind of service you're using and how that service is actually charging you. So you can actually go ahead and check the pricing page for more details, and they also have a calculator available here. So you can just go on AWS cost calculator. You can come on this page and you can just type out the service. Let's say if you want to get the service for this thing, it's actually cloud cost report, cost explorer. I think it's this website. If I just come down here, so let me just try to find it, get that thing. It's there. AWS cost. There, on pricing page. Yeah, just click on request a pricing code. It's like they are doing it like right. They have started doing it like in an email form. Earlier, I used to have come on this website and used to like this much query I will write or this much data I will scan, and then they used to give approximate results to me. But looks like that is gone. If I just go on go here, it is actually this thing. Okay, if I just come here, I use this thing only, lambda function without a free tier. Okay, if I just say number of requests, let's say I make 1,000 requests per month, and their request is like 10,000 seconds, that means 10 seconds each. Our amount of memory allocated is like say 512 MB, 512 not 215. Okay, so this kind of cost estimates you can do, and then you can just click on show calculation. So without free tier, you will be charged around $0.8 US.
So is there any escalation also happen if the charges?
Come again, please.
Is there any escalation also happens when the charges goes beyond threshold?
Sorry, I'm not able to hear you properly actually.
Now can you hear me?
Yes.
I'm asking, is there any escalation also happens when the charges goes beyond the threshold?
No, there's nothing like that you can do. You can go ahead and set up some email triggers, like when your current cost is more than this particular amount. AWS can send you emails, then you can look into your AWS services that is running. But there's nothing like that you can stop those services. Okay. And yes, like I have estimated, this is like estimated charges. Okay. I have given some hard coded values, and in real time it could be different. So obviously your charges can be more than this, and then as per depending on your country, you are charged taxes also. So in India, it's in India on your bills there is a 18% GST also charged.